Hello everyone. Namaskar. Raj Krishna this side. Let's solve this problem. We need to solve 3x plus sin x minus e power x equals to 0 by Regula Falsi method correct to 3 decimal places. Okay. So let's solve this. Before solving, if you are using calculator, fix your calculator to radians, not in degrees, because in this problem we'll whenever you see trigonometric function and use calculator, fix it to radians rather than degrees. Okay, so first step will be similar to bisection method, that will be find the interval in which the root lies. Okay, so if you check the value at 0, so fx is what we will be writing first, which is 3x plus sin x minus e power x. Now if you check f of 0, that will clearly be equal to e power 0, which is 1. F of 1, if I check, after fixing it to radians, make sure that you do so. So it will be 3 times 1, which is 3, plus sine 1 minus e. E will be shift ln, and in power you put 1. So that's it. The value which I am getting is positive 1, which is 1.123189. Now let me fix it to 6 decimal places so that it will not be a problem for me. So shift mod, and when I fix it to 6 decimal places. Fine. Now clearly, as you can see, value at 0 is negative, value at 1 is positive, so root will lie between 1 and 2. But just to reduce the number of iteration, what we do, we go more nearer to the root in this initial step only rather than in iteration. So in order to do so, let's check the value at zero point 0.5. So value at zero point 0.5 will be 3 times zero point 0.5 plus sine of zero point 0.5 minus shift log and enter zero point 0.5. So you are getting a positive value, that means 0.330704. Now we can say that root was lying between 0 and 1, and it also can be written as that root is lying between 0 and zero point 0.5. So the interval on which we need to work is 0 and zero point 0.5, between this. Okay, fine. Now what is the formula, what is the iterative formula in case of Regula Falsi method? It is also known as false position method. So iterative formula is iterative formula, and it will take lesser number of iteration as compared to bisection method, so we don't need to think much of making functions inside calculators, because in case of bisection, because number of iterations are larger, we think how can we manage, and we make some functions in calculator so that our work becomes easier, but not in this case, I think. Okay, so and the number of iteration in Newton Raphson is even lesser, so iterative formula is xi, let's say. Okay, I will be 1 2 3 4 so on, is a times f of b minus b times f of a divided by f of b minus f of a. This is important. Okay, and a and b are your intervals. Okay, so this is the value of a, this is the value of b. Fine. So if the value of function at xi that will come negative, you know that your value of function was negative, you can write like this also, minus plus. Okay, so if it will come f of xi will come negative, then you will replace the a value. If f of xi will come positive, you will replace the b value. B value means the uh, whatever value is after the comma, the second value in that ordered pair. Okay, you will change that. Okay, so coming to the iterations, so I will have my first iteration now, iteration number 1. So for that, my value of a is in this case 0. My value of b in this case is zero point 0.5. So if I find f of a, that means f of 0, that I have already found, that came out to be -1, and f of b is 0.330704. Let's find the first iteration value, which is x1. That will be a times. So a is 0. So 0 times f of b I am writing. I'm not writing that bigger value because this will anyway be 0, minus b times f of a, which is -1, divided by f of b minus f of a. So 0.330704 minus f of a, minus minus plus 1. So now let's calculate this. So this value will be, in numerator you have plus 0.5, in denominator you have 1 plus 0.330704, and the value which you are getting is 0.375741. This is the value which you are getting after first iteration. Now you have to check the value of function at x1. So value of function at this point will be, function is this, so 3 times 0.375741 and plus sine of, you can make functions if you want, that will make your task easier, otherwise it is a bit slower. So f of, and no, inside sine again the same value, 0.375 and 741 minus e power, so e power 0.375741. So the value which you are getting is 0.38 0.038115. Now in case of bisection, we don't need to have the exact value of f of x1, we just need its sign. Here apart from sign we also need value because it might be used in the next iteration. So now if you check the sign, it is positive, that means our new interval for iteration, this iteration has been finished. So we can write root lies between, because this came out to be positive, so we'll change the value of b. So now root lies between 0 and what was x1, it was 0.375741. First iteration is done. Let's move to the second iteration. So iteration number 2. So you have the value of a as 0. You also had f of a as, I think, -1. You have value of b as 0.375741. Value of function at this point is 0.038115. Okay. Now let's find the second iteration value, which will be a times f of b, that will again be 0, minus b times f of a, that minus minus plus 0.375741 divided by f of b minus f of a, so that is 0.038115 plus 1. So let's calculate this value. So this value is 0, so this is 0.375741. Okay, and this is being divided by 1 plus 0.38 0.038115. So this has come out to be equal to 0.361945. Okay, so if you check with the last iteration, it is matching up to 1 decimal place, and what was given in the question, up to 3 decimal place we have to match. What is the value at x2? This will be what was your function? It was, I think, 3x plus sin x minus e power x. So 3 into x, which is 0.361945, plus sine of same thing, 0.361945, minus shift ln 0.361945, and this has come out to be 0.003809. Of course, it's again a positive thing, so we'll make our statement as root lies between, the lower value will remain 0, upper value will now be replaced by x2, which is 0.361945. Don't make a mistake by replacing that by the value of function. You have to replace by value of x2. Okay, so we have done till 2 iterations. Now moving to iteration number 3. So for this, you have again value of a is 0, function value at a was -1, value of b is 0.361945, and value of function at b is 0.003809. You will find the x3 value, which will be a times f of b, again 0, okay, minus b times f of a, so plus 0.361945 divided by f of b minus f of a. So I am directly writing 1.003809. So if I find this value, it is 0.361945 being divided by 1.003809. So this is coming out to be 0. 0.360572. So fine. So now if I check with the previous iteration, it is now matching till 2 decimal points. So I need to make some more effort. Meanwhile, let's find the value of function at x3. So function was 3x. So 3 times 0.360572 plus sine of 0.360572 minus shift ln 0.360572, and it is coming out to be a positive thing, 0.000376. Okay, so our root lies between, again because it came positive, will not touch the lower limit, and upper limit now shifts to, not change by this value function, you have to change it by x3 value, which is 0.360572. Fine. So now let's move on to iteration number 4, with some hope that that will be our last iteration. So iteration number 4, value of a again 0, f of a again -1, value of b 0.360572, value of function at b is 0.000376. Now the fourth iteration value x4 is a times f of b, again 0, minus b times f of a, again plus of 0.360572, divided by f of b minus f of a. So that will be simply 1 point. Let's calculate it quickly. So this is 0.360572, 1.000372, sorry, 376. So this value is 0.360436. If I check with the previous iteration, I've got it equal till 3 decimal places. Were they asking up till 3 or 4? Up to 3 decimal places. So I think my task has been completed. Okay, done. So I don't think I need to go further for finding the value. Okay, if you need further root clear up to further decimal places, then you can obviously do that work. So I have got it equal, because if I see this x4 value and the value of x3 value, 0.360 is matching. Okay, and I only needed up to 3 decimal places, so I can say that root of, what was the equation, is x equals to 0.360 correct up to 3 decimal places. Fine. If you want, I can show you the correct answer also. Wait. So now currently we are inside our Desmos graphing calculator. So if I need, what was our equation? That was 3 times x plus sine of x. So sine is here, x, let's close this, minus of then it was e. So here we have e power x. So again power x, not right, equal to 0. So this, if I see the roots, is intersecting the x-axis twice, 0.36 and 1.89. So my root is obviously 0.36 something that was there, so it is actually matching with that. So if I see my calculations, then okay, fine, I would be happy with this. So this was it as far as this problem is concerned. We took 4 iterations. We started off with finding the interval, then getting close to the interval, and then applying iterations using the iterative formula one by one. So upon reaching fourth iteration, I realized the value of x4 and x3 was matching up till 3 decimal places. So I stopped there. Okay. And that was my approximate answer up to 3 decimal places. That's it from my side. You can watch out more problems as I have made the playlist iterative techniques and interpolation. So inside the playlist, you can get 4 more problems of this type. Thanks again.